All right, so today we are doing the day 2 notes. If you're following along in your textbook, it is section 2.3 and 2.4. In the packet of notes I gave you yesterday, we're right in the middle of the first page on the table of properties. And it should start right here with the identity property of addition. Everyone see where we're at? So the identity property of addition basically says if you add 0 to a number, you're not changing the number. So the identity is who you are, right? That's your identity. I am Mrs. Munden. It's my identity. If you add 0 to a number, that number, who that number is, does not change, okay? Identity property of addition. So an example using actual numbers would be 5 plus 0 equals 5. All right, any questions on this one? So the property of opposites says that for every A, there is an additive inverse, negative A, such that A plus negative A equals 0. So the property of opposites just says if you add opposites, you end up with a 0. So like 2 and negative 2, 5 and negative 5, negative 7, positive 7. Those are all opposites. When you add opposites, you end up with 0. So in your packet of notes, now you're jumping to the front of the second page. We're off the properties sheet. Now we're going straight to the rules for adding two numbers. If the signs are the same, you find the sum. Sum means add. Keep the sign the same as it was. If the signs are different, we subtract, we find the difference, and you keep the sign of the larger number. Now, larger is in quotes because technically the positive number is always larger than the negative number. It's which one has the greatest absolute value. So I always ask myself, did I start with more positives or did I start with more negatives? That'll be the sign of your answer. Do you guys have any questions so far? So are our signs the same or different? They're different. When the signs are different, you subtract the numbers and keep the sign of the larger number. So this is like 15 minus 4. Okay, we find the difference. We started with more positives than negatives, so my answer is going to be positive 11. All right, next we have negative 21 plus negative 36. And the parentheses here just help us keep the signs straight. Sometimes when you're writing it and you don't use the parentheses, it looks like one long plus sign. Or like if it's a minus, it looks like a long negative sign. So the parentheses just help us keep the sign straight. It doesn't mean multiplication in this case because the plus sign is outside of the parentheses. Okay? So these signs are both negative. They're the same. So we're going to add the numbers and keep the sign. So our answer will be negative 57. All right. Any thoughts on this one? Yes.
Wouldn't that be negative 3 plus negative 4?
Mm-mm.
No, I mean 3 plus 4.
Yes, yeah. Don't change the sign of the 3. When you have a minus and a negative, that's actually like a plus sign. Okay? Some people like to think of subtraction like as the opposite. So we want the opposite of negative 4, which is plus 4. Okay? Or just remember a minus negative turns into like one big plus sign. Okay? A lot of times I'll actually write on mine like that. You know, just kind of combine them. And then that's just regular old 3 plus 4 that you learned in 2nd grade. Any questions? All right, next we have 15 minus 32. Any thoughts on this one? Yeah, she said just subtract, but your answer is going to be negative. Perfect. Yes. Sometimes students want to think of this as like 15 plus negative 32. If that's helpful, you can write it out that way, like off to the side. When I was in high school, that's how they taught me to do it, so I sometimes revert back to that if I'm struggling with it a little bit. Because here it's really obvious to see that the signs are different, so we're going to subtract the numbers and keep the sign of the one that was larger. So we'd keep the sign of the 32. So if that helps you see, that's fine. Another way to think of it is like if you're taking away more than you have, if you picture a number line, now you're going into the negative side of the number line. And you go all the way in 17 spaces. Bless you. Any questions on that one? All right, here we go. Yikes. All right, both of these numbers are what? Yes.
Negative.
Yeah, this might be one. It might be helpful to like separate them with a plus, so then you can obviously see that they're both negative. Or you can just notice that they're both negative. You're already in the negative. You're subtracting, so you're going even farther into the negative. But we do have to deal with these decimals. Yes.
Question. So, like in this problem, can I just do like add a negative?
Mm-hmm. Yep. All right, so when we add decimals, I'm actually going to forget my signs for a second and just take care of the decimals. I know my answer is going to be what? Negative. So if you want to write a negative down here and tell yourself, like, I'm going to come back to that, that would be fine. When we add decimals, we have to line up the decimal point. If you want to fill in zeros, you can. And then we just add the columns, okay? So 6 plus 0 is 6. 2 plus 8 is 10. Carry the 1. And then the decimal drops right down. So my answer here is negative 4.06. All right. Signs are different, right? We have a negative plus a positive. So I need to subtract the numbers, keep the sign of the one that's bigger. I don't know which one's bigger at the moment because I don't have common denominators. So what is the common denominator going to be? 6. Good. So I am going to multiply the first one by 2 and 2. And then the back one by 3 and 3. So is my answer going to be positive or negative?
Negative.
Negative, yes. And then you just subtract the 4 and the 3. What do you get?
1%.
1, and then the denominator stays the same. We still follow the rules for adding and subtracting fractions. What are your questions? All right, so G looks like a fun one. 15 minus 12 plus 9 plus 6 plus negative 22. All right, the first thing I'm going to do is clean up my sign. So instead of plus negative 22, I'm just going to write it as minus 22. Like I said earlier, some people prefer this because then you can definitely see what sign goes with the 22. I don't particularly care which way you do it, okay? Whatever works for you, whatever makes more sense for you, go with that, all right? Now, they skipped some steps, so let's talk this through. I like the magical answer just pops up. When doing these, I would add or subtract from left to right. We talked about how order doesn't really matter in addition. So if you know to keep, for example, this sign with the 12, you can add in whatever order you want, or this sign with the 22. That's fine, but a lot of times when you jump around, with positive and negatives, you'll get them a little bit mixed up. So what I would do is just go left to right. So this right here gives us 3. So you'd have 3 plus 9 plus 6 minus 22, and then just keep working left to right. So 12. And then, what's that, 18? And then that's how you end up with a negative 4. All right, questions? Yes?
So I did the 15 minus 12 and the 9 plus 6 at the same time.
Yep, that's fine.
And then just did the 3 plus the 15 minus 22.
Yes, the only thing is you gotta just keep the signs correct. The time when that would not work, sometimes students want to do like 12 plus 9, and they'd say 21, and then they'd subtract 21. You can't do that because you just accidentally made the 9 a negative, okay? So as long as you know that the number sticks with the sign right in front of it, you're fine. But again, I think something like this, left to right, seems to be the easiest way to not confuse your signs. So that's the way I'll do it. All right, H, what do you want to do?
Negative
That's a
88.
big old number.
You just want to give me the answer?
Oh.
Negative 88 is correct. So the way you do this one, the signs are different. So you're going to subtract the numbers and keep that negative because 104 is obviously more than 16, right? You have more negatives than you have positives. Questions? All right, here's I. All right, so order of operations is coming into play here. You want to simplify your parentheses first. So negative 7 plus 3 is negative 4. And negative 4 minus 2 is negative 6. They're both negative. Add the numbers. Keep the negative sign. You get negative 10. Questions? All right. Now we're getting into some fun. 17 decreased by negative 4. What does it mean to be decreased by? Subtract. So this is actually 17 minus negative 4. Well, what's minus a negative? Very good. 21. I went kind of quick there. Everybody stay with me?
Oh, snap. I wrote the wrong thing on the line.
Everybody keeping up? All right, next we're going to look at something called combining like terms. So everybody see where we are in the notes? Combining like terms? About halfway down the page. So a term is a number, variable, or product quotient of numbers and variables separated by plus and minus signs. I would underline that part. Terms are separated by plus and minus signs. So if it's multiplication or division, that's still one term. Okay? Like 7 times x times y times 5. That's all one term. The plus and the minuses, those are what break up terms. All right, here's an example. Those are all terms. And you can see in the back, some people, like every year, a few people will tell me there are 4 terms right here. That's not true, okay? it's all multiplication, so it's all a single term. A polynomial is a group of one or more terms. So if I put, let's say, like a plus sign in between each of these, that would be a polynomial. All right, a group of terms separated by plus and minus signs. Now, depending on how many terms a polynomial has, we have special names for them. If there's one term, we call it a monomial. Have you ever heard like people say like, we're going to go mano y mano? That means like one-on-one, right? One, mono. Or like the game Monopoly. The goal is for one player to own everything, mono. Mono means one. So if something has one term, we call it a monomial. Here's an example of a monomial. 3x. All right, if it has two terms, like 5x plus 2, we call that a binomial. Like a bicycle has two wheels. Bi means two. Two terms. Binomial. And then tricycle, right, has three wheels. You guys heard of these things? Mm-hmm. Yes, so if it has three terms, we call it a trinomial. Anything above 3, we just go with polynomial. Poly means many. So if it's more than 3, it has many terms. It's just a polynomial. Any questions on these vocabulary terms? All right. Lots of vocab today. A constant is a term with no variable at all. So when you were listing the terms, you wrote down 15. 15 didn't have a variable. We call that a constant because no matter what you plug in for x or y or p or whatever, that term holds a constant value. It is not changing depending on what your variable is. All right, and coefficient is the numerical factor in a term. I always like to think of like your co-workers or people that you work with. Coefficient is a number that works with a variable. Okay? They coexist. They're right there next to each other. Coefficient. All right, here come some examples. Example 1, name the coefficient. So this goes right along with what we just talked about. 5x squared. What's the coefficient? The 5. It's the number that works with the variable. Not to be confused with the exponent. That's something way different. What's our coefficient on part B? -2. Yes, keep that sign with the coefficient. All right, here's where it gets a little tricky. When you don't see a coefficient, it's a 1. Yes. Very good. Sometimes people like to write a little 1 up front just to help remind themselves. But yes, when there isn't a visible coefficient, the coefficient is 1. Sort of the same idea here. We have a 4 in the denominator. There's no number in the numerator. So I know it's like a 1 right there. And since there's a negative sign, it's like a -1. So the coefficient would be -1 over 4. Or -1/4. All right. Terms are separated by what? Plus and minus signs. So I have 1, 2, 3 terms. Part B. Now double check, sometimes you can combine the like terms and then there's a different number of terms. So make sure that the like terms are already combined. Like terms have same variable, same exponent. So none of those are going to combine, but we have 1, 2, 3, 4 terms. Boom. How we doing? Y'all still with me? That's a very long lesson. Thanks for hanging in there. All right. Yes, of course. Like terms. Terms that have the same variable with the same exponent. The coefficients don't matter. Okay, the coefficients don't have to match. The variables have to match. The exponents have to match. And then we add or subtract the coefficients. That's where those come into play. Are these like terms? Yes. M and M, like terms. Are these like terms? Yes, x squareds and x squareds. The coefficients don't matter. The coefficients matter once we go to combine them. But when you're just looking to see if they're alike, you look for the exponent, you look for the variable. Same variable, same exponent? No, so these are not like terms. Questions? All right. X squared, y. So are these like terms?
Yes.
Yes, they are. Why are you shaking your head now? I saw a few people do this. The nose, the head shakers. Yes?
Because there's an exponent of 2 for n, and not on the
Right. The m, one of them has an exponent of 2. One of them doesn't have an exponent, which when there's no exponent, it's like having a 1. And then the n doesn't have an exponent, but then the n does have an exponent. So these are not like terms. Same variable with the same exponent. This is a yes, even though the order is different. Remember we learned yesterday that order doesn't really matter in multiplication. So having an xy squared and a y squared x is the same thing. So these are like terms. A big ol' yes. If you wanted to rewrite it so that they're in the same order, you could. Any questions? All right, we got to keep going. We got lots to do. Remember, no parentheses in the final answer, and we're following the same rules that we learned earlier today. (15x squared plus 7x squared). So they're like terms, right? When they're like terms, I like to underline them in the same way, just to show myself what they are. Yes, you should be writing this problem in your notes.
No, that. Next to example 4. Oh, because it just says simplify.
No, you don't need to write that. That's just kind of a reminder. What is 15x squared plus 7x squared? 22x squared. Good.
Do it like 22x to the 4.
Oh, very good question. The variables and the exponents do not change when you're combining like terms. The variables and the exponents, that when they match, that just tells you that you have like terms, and then you add or subtract the coefficients. I like to think of these as like 15 apples. It just tells you what you're adding. 15 apples and 7 apples. That doesn't give you like 22 apple bananas, right? You don't change the variable, you don't change the exponent, you just add or subtract the coefficients. Questions? All right, let's try part B. So what's the like terms here? Yes, ma'am.
9 y to the third and 13 y.
Yes, the y to the thirds are like terms. And then we just add or subtract the coefficients. So it's like 9 minus 13, and then the y to the thirds just sort of come along for the ride. So that would be negative 4y to the third. And then in the back, the plus 3, nothing combines with it, so you just write it on the end. Now from here, these terms are not alike, so you're done. A lot of students mistakenly try to make this like a negative 1 y to the third, something crazy. Don't do that. They're not alike. You are done. If you couldn't combine them up here, you still can't combine them down here. Any questions? All right. Part C. What are the like terms? Yes, ma'am.
60 and negative 2d.
Very good. The D's are going to go together. So that's like 6 minus 2, essentially, and then the D just sort of comes along for the ride. Questions? All right, here's D. All right, like terms or not? Yes, they're both like terms here. So you're basically just doing 18 minus 24 and keeping the P. We're taking away more than we have, so we're entering the negative. And the difference between 24 and 18 is 6, so negative 6p. All right. Any questions on combining like terms? There's a few more examples in your notes, but I want to have time to look at your tests real quick, so we're actually going to jump to the summary if you guys are cool with that. So what did we learn today? We learned a lot. Combining like terms, we learned to add and subtract signed numbers, right? And then we learned about like terms. All right, if something is still confusing you, go ahead and write me a little sentence about it. We'll start class by talking about that tomorrow. And then give yourself a quick sample question. I am going to give you your homework first, and then I'm going to give you guys your tests real quick so we can go over them.